Ever wondered how Google seems to know exactly what you're searching for? Or how your GPS calculates the quickest route to your destination? Behind the scenes of these everyday marvels is a concept as old as civilization itself, yet as cutting-edge as tomorrow's technology. These are the unseen architects of our digital world, the silent maestros conducting our online symphony. They're as ubiquitous as the air we breathe, yet remain largely invisible. The secret behind these seemingly magical capabilities? Algorithms. So, what exactly is an algorithm? Now there's a question that's been asked by many a curious mind. You might have heard the term being thrown around in tech circles, or perhaps you've stumbled upon it while exploring the world of mathematics and computer science. But what does it really mean? Let's break it down. At its core, an algorithm is nothing more than a set of instructions. It's a step-by-step guide designed to perform a specific task. Sounds simple, right? But don't let the simplicity fool you. The beauty of an algorithm lies in its precision, its efficiency, and its ability to solve complex problems. Now, you might be thinking, that sounds a lot like a recipe. And you're absolutely right. Think about it. When you follow a recipe, you're following a set of instructions designed to achieve a particular outcome, a delicious dish. An algorithm works in much the same way. Consider this. You're playing a board game for the first time. You've got a set of instructions in front of you, telling you what moves to make, when to make them, and what the end goal is. That's an algorithm in action, but algorithms aren't just about baking cakes or winning board games. They're everywhere, from the GPS systems that navigate us through unfamiliar cities, to the search engines that help us find information online, to the social media algorithms that determine what content we see on our feeds. In mathematics and computer science, algorithms are used to solve complex problems, optimize processes, and make sense of vast amounts of data. They're the backbone of modern computing, powering everything from simple calculations to artificial intelligence. So the next time you follow a recipe, play a board game, or use a search engine, remember, you're interacting with an algorithm, a set of instructions designed to perform a specific task. Simply put, an algorithm is a set of instructions designed to perform a specific task. Algorithms aren't just a tech thing, they have a long-standing history in the world of mathematics. Now let's delve into the fascinating realm of mathematical algorithms. Algorithms in mathematics serve as systematic procedures to solve complex problems. They are like recipes, where one follows a series of steps to arrive at a solution. Just like a recipe, an algorithm has a specific order of operations that needs to be followed to get the right result. A classic example of a mathematical algorithm is the Euclidean algorithm. This ancient algorithm, named after the Greek mathematician Euclid, provides an efficient method for finding the GCD. The Euclidean algorithm repeatedly subtracts the smaller number from the larger until the two numbers become equal. This final number is the GCD. Another remarkable algorithm is the sieve of Eratosthenes, named after the ancient Greek scholar. This algorithm is used to find all prime numbers up to a given limit. It systematically eliminates multiples of each prime, starting from 2, the smallest prime number. The numbers that remain are the prime numbers. These mathematical algorithms provide efficient solutions to problems that have been puzzling humans for centuries. They're not just equations on a chalkboard, but powerful tools that help us understand and navigate the complexities of the world around us. Now let's dive into the realm of computer science. Picture this. You are at a library with millions of books, and you're looking for one specific title. You could start at one end and work your way through each book, or you could use the library's catalog system, which sorts books by author, title, and subject. This organized system is similar to an algorithm in computer science. In the heart of computer science, algorithms play a vital role. They are the set of instructions that a computer follows to solve a problem or perform a task. Let's delve into some examples. Think about sorting algorithms, like quicksort and mergesort. These algorithms arrange data into a particular order, much like our library catalog. Quicksort, as the name suggests, is known for its speed. It picks an element from the array of data called the pivot and partitions the other elements into two groups, those less than the pivot and those greater. It then repeats the process on the two partitions. On the other hand, mergesort divides the data into half, sorts them separately, and then merges them. Both these algorithms have their strengths and are used depending on the nature and amount of data. Now let's look at search algorithms, another cornerstone in computer science. Binary search and depth-first search are two examples. Binary search is like looking for a word in a dictionary. It starts in the middle and eliminates half the data set in each step, dramatically reducing the search time. Depth-first search, on the other hand, is used in scenarios like maze solving or route finding. It explores as far as possible along each branch before retracting. These algorithms and many more are the unsung heroes behind the scenes. They help computers process information efficiently, making it possible to sift through vast amounts of data, find the shortest route to your destination, or even recommend your next favorite song. Without these algorithms, our modern digital world would grind to a halt. So, we've journeyed through the fascinating world of algorithms. Let's recap what we've uncovered. Algorithms, in essence, are sets of instructions to solve a problem or accomplish a task. They're foundational in both mathematics and computer science, acting as the brains behind the operations. In mathematics, algorithms are like navigational charts guiding us through problems. We've seen examples such as the Euclidean algorithm for finding the greatest common divisor, or long division, which we all learned at school. Shifting gears to computer science, algorithms become even more critical. They're the engine driving our digital world. Think about the sorting algorithms that order our data, or search algorithms that power platforms like Google. So, algorithms are everywhere, from the math problems in a classroom to the digital platforms we use daily. They're silent yet powerful architects of our modern world. Next time you use a search engine or follow your GPS, remember the invisible algorithms working behind the scenes to make your life easier.